All right. Okay. So, well, happy Friday, everybody. Happy Friday. And I heard some of you guys had midterms this past week, so I hope everything is feeling okay. It's like you have the post midterm I don't know, ennui that sensation. But okay. So I think we left off somewhere around here. We talked about character classes, and these are just kind of shortcuts. So you can do /D and /D, /w and /W, /little s, /S. And these will either do all the digits or non-digits, all the word characters or non-word characters, white space characters or non-white space characters. There's also other character classes that you could use on kind of POSIX systems, which would be, your Mac and your Unix and Linux and things like that. And those work, and people understand them. I didn't put those in my slides, but that's what we have. Okay, and we talked about what the white space characters are, and /S is useful as it catches both the breaking space and the non-breaking space, which is impossible to tell apart with just the naked eye until you look at like the things. Okay, so we'll just get into some examples, and where will this return true? We've got P followed by a digit, P/D. So this will return true for the P0N, but it will return false for everything else, because in everything else, P is followed by something not a digit. So it's going to be false, 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 true, false, false, false for the other three. Okay, and here we have P/D, so P followed by a non-digit, and it's going to be just kind of the complement or the inverse of this, right? So everything where it was false here will be true, and everything where it was true will become false here. And so here we get true, 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 false, true, true, true. Okay, and here I have P/W, \W, so non-word characters. So what were word characters? Word characters were letters. Word characters were numbers and underscores. Okay, letters, numbers, and underscores. So it has to be P followed by a non-word character. And so that would just be this one where we have a dot. Okay, everything else is a word character. The letters, the numbers, I don't have any underscores here, but the only one where it's true is for the P dot, right? So P followed by something else here. Oh, okay, yeah. So here are the POSIX character things. I don't have examples of this, but this also works, and you can do this. And so alphanumeric is very much like /W, except it doesn't include the underscore. Okay, and we got letters, digits, upper, lower, or lower, upper, and then the space, and then punctuation, print, graph, and then hexadecimal digits, and then ASCII control characters. Okay. Oh, I guess, sorry, I did have examples here. Okay. So all you have to do is you just throw this in here, and then so we just say, what has any letter, and everything is true, has any digit. The only one with a digit is the P0N and the PWNED or 3D, the pwned. Okay, and that's what we have. Does this word exist still in the gamer community? I have not. I have not played online games in a very long time. Well, I mean, like multiplayer, but this was kind of the insult when you were victorious in a poor sport. People used to use it in TF2. Okay, depends on the game. Yeah. So different games have different communities. So okay, okay, anchors is used to kind of, is not a character, but it's a position, right? And so maybe you're looking for something, but it has to be at the start of the string, or it has to be at the end of the string. And so you would use an anchor to indicate that it has to be at the start or end of a string, or the word boundary. For POSIX, the single brackets worked for me. Oh, did they? Single brackets work for you? Okay. All right, well, I'll have to fix that. But okay, so start or end of a string and word boundaries, okay? So /b is a word boundary, meaning the edge of a word or something that's not a word boundary. P.n is true for alpha because it's got the letters P and the letter N. It would not be true if it was P alpha N, but it returns true for just alpha because P.n just has letters P and N. Okay, so let's go ahead and just take a look at anchor examples. Here we're going to run replace all. Replace all is going to go through the string, and it's going to replace all instances of this pattern with this text. So we're going to say anytime you find the pattern THE, replace it with a dash. Okay, so we're going to go through and we're going to replace the dash and the right here. And so we get quick brown fox jumps over dash lazy dog, dog. Okay, and this is intentional that I have dog repeated here. Okay, here I put in a caret. Okay, so again, the caret means start of the string. You can also do /A, and $sign is end of a string, and you can also do /Z. Okay, and so this one, because it has a caret in front of it, it's only going to match the first the. It's only going to match the one at the start of the string, and it will not match the THE because it doesn't match the pattern start of the string THE. Okay. Here, this is /A THE is the exact same thing as using the caret. Okay, so it matches the same thing. Okay, and then here it's going to replace THE at the end of the string. Okay, and there's nothing will get replaced because there's nothing in here that matches THE end of the string. Okay, because we have THE and a space and a THE and a space, but these are not the end of the string. So that will not replace anything. Okay, over here we've got dog, 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 and it replaces both instances of DOG with a dash. Here we've got dog $, and it will replace the DOG only at the end of the string. Okay, and that's what we have. So that's the anchor going at the end. Okay, why are there 2 backslashes for /A? And that's just because R has this kind of quirk where the backslash itself is a meta character, and so you have to escape the meta character. And so you have to do 2 backslashes, okay? And so it's kind of the same with the /Ds. All of those things, you have to use 2 backslashes to escape it. Okay, word boundaries. Word boundaries are wherever there is a word boundary. So that means words, space, jump, space. So these spaces are word boundaries, and it's going to replace all the word boundaries with a dash. Okay, so effectively here, it's going to be everything where there's a space will get replaced with a dash here. Okay, all right, and so actually technically the spaces themselves don't get replaced with dashes. Sorry, the word boundaries. So we have a word boundary at the in front of the W and after the S, and then there's a space, and then we have another word boundary in front of the J and after the P. Is that okay? That by replacing the word boundaries, it looks like we're not replacing the spaces, we're replacing kind of the, there's kind of like an invisible, it's not even a character, it's an invisible thing that says this is the end of the word, okay? And it appears on both sides of the words. Okay, all right, where will the non-word boundaries go? Okay, so So every place where there's not a word boundary, okay, which is between the W and the O and the R and the D and the S, those are all non-word boundaries, okay? And there's no physical character here, but they all represent non-word boundaries. So we're gonna get dashes between W and O and R and D and S, okay? And then dashes between J and U and M and P and things like this, right? So if you wanted to, I don't know, you're trying to explain how things are read at a spelling bee or something, and you didn't want to have to go through and type a dash between every single letter, this is a shortcut to get everything where there's a dash in between every single letter, right? So, okay, all right. So here I have the words are words, jump, jumping, umpire, pump, umpteenth, and lumps, okay? And here we're doing //b, little b, meaning we want the word boundary. So remember, the little thing, little letter is the thing. So little boundary, we want the word boundary. Capital B would be not a word boundary, right? So we want word boundary, UMP gets replaced with a dash. Okay, so which words will get replaced with a dash, or what words will be affected? Okay, will jump be affected? No. What about umpire? Yes. Okay. And umpteenth? Yes. All right. So indeed, jumping is not affected, but umpire is, because it is at a word boundary. It's at the start of a word basically, and umpteenth gets replaced here. Okay. Here, if I do capital B UMP, which ones will get affected? Okay, we'll get jump and jumping, and pump and lumps. Okay, these, the UMPs will get replaced with a dash here. Okay, so we have the UMP and jump. UMP and jumping gets replaced. Umpire is left alone. P, and then the UMP and pump, and then the UMP and lumps. Okay, here I've got UMP with a /B. So this is going to be replace the UMP at the end of a word. All right, so that's going to get the UMP and jump, but it's going to leave jumping and umpire untouched. It'll get the UMP and pump, and it will leave these ones untouched. Okay, so we're just going to get the jump and the pump. The UMPs there will get replaced with dashes. All right, and this is UMP followed by a non-word boundary. So this will basically get the UMPs that are not at the end of the words. So that will replace the UMP and jumping, and umpire, and umpteenth, and lumps. Okay, is that all right as far as word boundaries go? What word boundaries and non-word boundaries are. And this can be useful, especially if you're looking for, you know, sometimes you're looking for something like a short, like you're looking for California, but in addresses. And so you have CA, but CA appears like so many places, right? So if you just do a control find on CA, not control find, but if you just search for CA, it's going to highlight a whole bunch of stuff. But you can just say, you know what, I want CA, you know, I want to, not necessarily like a space, okay, but you can just do word boundary CA word boundary, and then it'll find, you know, CA followed by a comma or a space or a period or something. /B combined with other characters only mean one side boundary. Standalone means two side. I'm sorry. We have a question. /B combined with other characters. Yeah, so here the boundary, we're only looking at the boundary on this side. Okay, there's nothing that matters here. Whether there's a boundary or a non-boundary, we don't care about this side. Okay. Is capital B, is / capital B similar to UMP / capital B? Okay. So is this similar to this? And well, we can look at the results and we can see that they are different in that here we need a non-word boundary followed by UMP. So we're going to get any time where UMP is not at the beginning of the word. So that's going to be the UMP after the letter J, the UMP after the letter J here. and then the UMP after the letter P here. Okay, over here, this is UMP followed by a word boundary. So we're going to get UMP where it's not at the end of the word. Okay, so the difference here is with non-word boundary UMP, we got this, but with word boundary UMP word boundary, we're not going to get this because this is the word bound. There is a word boundary after the letter P here. Okay, but we're going to get this one because there's a non-word boundary after the letter P. I hope that clarifies the difference between these things. Okay, and again, the best way is just like practice this kind of stuff. So I think, what slide am I on? 95 here. Okay. At the beginning, I gave you kind of this resource here. Well, so this one might be over here. Let's just go to this one. This one's simpler. All right. And you can just take some text and you can just play. Okay. I'm going to just paste the text right here. And then we want to see, okay, here's UMP. And if I do so here, just use a single slash, okay? So I'm going to do slash capital B, and then you can see which ones get highlighted. What if I do slash capital B in the front? What if I have it slash capital B here, okay? Then it only gets UMP in the middle of a word. If I do want a word boundary, if I don't want a word boundary, this actually has no matches here, things like that, right? So you can see how this works. So this is a good place. You can just put in some text and you can see if your pattern up here matches. Okay, so this was just a little example. Okay, what's the difference between this, this, and this? Okay, so the caret outside is going to be an anchor. So this is going to match strings that begin with a digit. The caret at the start of inside a character set is negation. So this will be matches a character that is not a digit. And then over here, we have the caret inside a character set, but is not at the start, is the literal character. So it's going to match anything that is a digit or the literal caret. Okay. So these are, so this used to be like a good midterm question, but now that it's open note, I don't know if it's as useful now, and I got to figure out. Still working on trying to write your midterm. It's like the great burden that I have here. Okay, so this that was all on character sets, and we can get real interesting with quantifiers. Okay, quantifiers. This makes things exciting. Okay, so we can do star. Star is 0 or more, so the thing or more. Plus means you must have it match 1 or more. Okay, and then I'll talk about what it means to be greedy. Okay, and then we've got question mark, which means 0 or 1. And then you can use curly braces to indicate exactly how many you want. Okay, so you mean you want exactly 3. You can do 3 comma, which will be 3 or more. Or you can do 3 comma 5, which means, 3, 4, or 5. Okay, or whatever's in that range. Okay, so here we're going to replace all space characters with a dash. Okay, any space character. So we're going to come along and we're going to replace all the spaces with a dash. And there you go. Okay, here I've got non-space characters. Anything but the space characters will get replaced with a dash. Okay, so this is like intercepting some kind of secret code or something, and you get a bunch of dashes, and it matches this exactly. Just everything that the space remains, everything else got replaced with a dash. Okay, here we want anything that is non-white space. Okay, so basically everything that matched here. Okay, but we've got a plus. So this says one or more, right? So the plus means one or more, okay? And it's greedy. So if it can replace multiple with just one, it's going to. And so this will just turn into this, okay? Everything here, this whole thing matches this, and so this gets replaced with just one dash, okay? So it's going to just try to maximize this. So this whole thing just gets replaced with a single dash, right? Because it's matching this greedy. And so it takes the biggest thing that still fits the pattern, and we get that. Okay, and this is any one or more word characters. So what is going to be the difference between this and this? What is the only thing that's really not a word character? Here. Other than the spaces, what's not a word character? The comma, yeah, okay. So what we get is pretty much the exact same thing here, except this 9,876 gets replaced. The 9 gets replaced with a dash, and then the comma remains, and the 876 gets replaced with a dash. Okay, whereas before the whole thing just got replaced with a single dash. Okay. All right, let's keep taking a look. Okay, we're going to say every digit, any digit will get replaced with a dash here. Okay. Yeah, underscore counts as a word character. Underscore, letters, numbers, and underscores count as a word character. Okay, so here we're going to say any digit replaced with a dash. All right, so we get this dash 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 and dash 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 dash. Okay, here we're going to replace anything that's not a digit with a dash. All right, and so that includes all spaces. Okay, so everything that's not a digit gets replaced with a dash. Okay. If we only wanted letters, we would have to use kind of a character class and do, A through Z, A through Z. Okay, and this says one or more digits. Okay, so basically, all of these things where we see kind of multiple dashes in a row, those will just get replaced with a single dash. Okay, so we're going to get this. Okay. Okay, and then lastly, anything that's not a digit will get replaced with a dash, okay? One or more non-digits. So basically, all of the things, anytime where you see multiple dashes here, all of those will just get replaced with a single dash, okay? So we're going to end up getting one dash here. This dash remains. We get one dash between here and here, and one dash between here and here, okay? And then so this thing, if you remove everything with a non-digit, it suddenly looks, I don't know, kind of like a phone number or something. There you have that. All right. So here, this is only going to match 0 or 1 digits. Okay, 0 or 1 digits, and it reads left to right. It reads left to right. So if it finds the digit, we're going to replace it with a dash. Okay, and so this is an interesting thing that results. Okay, what you end up having is you basically have the word boundary counts as a 0 digit. 0 matches 0. Okay, and so basically all of these instances you have 0, 0, 0. Okay. And so all of these kind of word boundaries and non-word boundaries will count as a matching as 0. Okay. And then we get to 1996, 1996, and where it can replace it with 1, it does. Okay. So it gets. So I think. Let me think what happens. I think we get the 1, the 9, the 9, and the 6 all get replaced, but then I end up having an extra dash here. So what is that? I think it's the word boundary here. Which one is it? I have to kind of remember how exactly it counts the things. Okay, but we're going to get kind of these. I think either the word boundary at the end counts as its own, and so so they get replaced. Okay. Whereas here, I'm going to do /d curly brace 3, and it's going to find three digits, and replace 3 digits with a dash, and it reads left to right. Okay, so what it does is it goes the year, and then it comes to 1996. All right, and it says, we've got 199, and it reads left to right, so it's going to replace the 199 with a dash, and then it finds the 6, and it says, okay, the 6, I can't do anything with that, so it just leaves that intact. Okay, 310 matches, so it gets replaced. Combo 123 matches 3 digits, so that gets replaced. 1 2 3 4, the 1 2 3 matches, but the 4 does not. Okay, because it's just reading left to right, and so that gets replaced like that. Okay, here we're saying anywhere from 2 to 4 digits. Okay, and it tries to do as much as it can, and so it's going to replace 1996, as that's 4. 310, 123, 1234 gets replaced with a single, and then but the single digit 5 does not, because it doesn't match this thing where it has to be between 2 and 4 digits. Okay, is that all right? This all of the quantifiers here. Oh, you know what? I forgot to give you some answers. It is 4th week. I'll go ahead and give you 2. 4th week Friday, your first 2 answers are C and B. C as in cat, B as in bear. C and B. The first one is C. The second one is B. Okay. All right. So what is greedy versus ungreedy matching? Okay. So quantifiers by default are greedy in that they're going to try to capture the most. They're going to try to get the longest match that still matches the pattern. Okay. If you add a question mark, then it makes the match ungreedy, and it will return kind of the shortest match. Okay, it reads left to right. Okay, so when it's looking for what matches, it reads left to right, and when it's greedy, it's going to try to find the longest thing that matches. Again, starting left to right, it's going to find the longest thing that matches, and then it ends, and it will either replace or pull that out. Whereas ungreedy, it's going to start, and as soon as it finds something that can end it, it's going to end. Okay, so here we're saying we want to find everything P dot star. So remember, dot is the wild card. Dot is any character. So that's either any character that's not a new line character. So spaces, punctuation, letters, everything matches. Okay, so this says we want to start with a capital P, and we're going to take any characters, spaces, letters, anything, and we want our pattern to end with an R. So where is it going to end? It's going to start with the capital P. Well, we got Peter Piper picked a peck of pickled peppers, and it's going to end here. It's going to find this last R, and it's going to end here. Okay, and so it pulled out everything. So extract will tell you what text matches this. Okay, and the text that matches this is this. Okay, the star is 0 or more. Okay, so the dot is any character, including spaces, punctuation, and digits, letters, all of that. And the star says 0 or more. So here we want as much as we can. Okay, so we get this. If I do dot star question mark, the question mark makes the star ungreedy. Okay, and so it's going to say, all right, start with the capital P, and then take 0 or more 0 or more characters. Okay, 0 or more characters, and but don't get as much as you can. End as soon as you are able to. End as soon as you are able to, where it's going to match this R. Okay, so it's going to come at P, and then it's going to find, okay, we're trying to end the pattern. We need to find an R in order to end the pattern. So we're going to get the ETE, and then we find the R and we stop there. Okay, because as soon as we get this matches the pattern, and we're done. Is that okay? So both of these start with a P and end with an R, and have a variety of characters in between. Okay, but this one it took the most that it could get, and it got almost everything. It didn't get the S in the text, but it came all the way up to here. Whereas this, it took the first R and then it exited. It quit. Okay. So again, remember we read left to right. So here we're going to say take everything, find all matches, right? So this was string extract. This one just does the first one. I'm going to do string extract all. Okay. So we're going to do P dot star question mark. So ungreedy matching until we get to the R. So it reads left to right. So we're going to find, what are we going to get? We're going to get Peter. That's going to be the first match. And then we're looking for a capital P here, and we're going to get Piper. And then are we going to find any more matches here? We will not, because it starts with a capital P. So we're going to get Peter and Piper. Okay. What if I do capital P or lowercase p with ungreedy matching ending with an R? Okay. So we're going to get Peter. We'll get Piper. And remember, we read left to right. So what's the next thing that we're going to get? We're going to start with this P. And we're going to get, remember, we read left to right. So we're going to start at this P and we go, okay, well, that matches. That starts the match. And we're going to end up at picked a peck of pickled pepper. And this matches, okay? Because remember, it reads left to right. So it's not smart enough to be like, oh, I could have just ended here and just gotten the PER, because that would have been the shortest P something matches with an R, right? Okay, we have questions. Wait, the star goes with the dot or the R? So the star goes with the dot, okay? So you put, I want a dot and I want 0 or more dots, okay? Dot is wildcard any character. Star means 0 or more any characters. And then the question mark says, as far as this star goes, be ungreedy, okay? All right. Is that okay as far as how it reads this one? Okay, so that's ungreedy matching. And yeah, again, just play around with a site like this, okay? And you can say like, okay, well, I want to just get P dot star, okay, and that matches a bunch. Okay, so here, so if I just do lowercase p dot star, okay, and it matches this, right? And then now you can do like, well, I want this. If you don't want, you can say, well, I only want word characters, right? I don't want the space, okay? I don't want a space in there. And now I've got capital P, lowercase p, followed by word characters and ungreedy matching, and then ending with an R, right? And so this will find all of these things, right? Or you can say like, I want a word boundary, so I only want words that start with P. Okay, so we got proudly, patterns, patterns, Peter, Piper, Pepper, things like that. Okay, so I think this is a really handy tool as far as just testing out and just kind of exploring and learning your regular expressions. Yeah, this means only one. Okay, only one. So if I have yeah, I don't know. This is just one. You can do multiple things like that. Okay. All right, let's talk about grouping and capturing. Okay, you can put parentheses around kind of a pattern, and that's going to represent a group. all right? And it's going to group together parts of the regular expression. So parentheses can also be used to create capture groups, okay? And any matches of the pattern defined by the parentheses can be referenced by group number, either for modification or replacement. So this is an interesting thing that gets like into advanced regular expression stuff, but really powerful things, okay? If you put in a question mark, question colon, okay, after the opening parentheses, this becomes a non-capturing group, right? So here I've got the pattern ABC as a group, DEF as a group, and then GHI is going to be a non-captured group, right? So this is going to create a capturing group for ABC, capturing group for DEF, and GHI is going to be a group, but it's not captured. And you're going to use match or match all with your grouping, capture grouping stuff, okay? So this is kind of, this is what we have. You can use the OR operator to say OR, and it goes, it reads left to right. So it reads, and it goes in this preference, right? So we got A, this matches the text. So here we have A, B, C, D, okay? But it's going to capture the BC, okay? This will match A, B, C, but it will be a non-capturing group. A, B, C, D, E, F, G, H, I, it matches this literal text, and it creates groups out of this, okay? And then if you want to use ORs to do something like this, again, we'll do that. And then if you're gonna, you can use replace, and you can reference the captured groups, right? This is often useful. So captured groups are best when it's not just literal text, but you're using kind of character classes like digits and operators and stuff, okay? So let me show you a few examples of how this works. So BCDEF GHI is going to match BCDF GHI here, okay? And it's going to capture the BC and the DEF, okay? And the GHI must be present, but it's not going to get captured. And so this matches this exact text, okay? And then it pulls out, extracts out, or matches the capture groups defined by the parentheses without the non-capture operator. So it's going to pull out BC and DEF, okay? It doesn't quite make sense to do it for a literal example, but I'm just starting off with a literal example, and then we'll see how it gets useful, right? So here I've got BC, DF, GHI, but I is capital, and therefore it's not going to match the pattern, okay? Because this letter here, the I here, that doesn't match, so there's no match. Okay. All right. Here's an example where I have a capture group, okay, and I have the OR operator, and remember it reads left to right, okay, so it's going to search for these things, and we're going to pull out basically all of the titles. We got Mr.Smith, Mrs.Lee, Ms.Garcia, okay, and it says, okay, we have found a match with the MR, we found a match with the MRS, okay, and we found a match with the MS. And so this is, when you do match all, it finds the text that matches, and then the capture group. And here the entire pattern is the capture group, so it kind of shows the whole thing, okay? Now notice, why are there two columns? So the first column is the text that matches the entire pattern, okay? What matches the pattern? So here, as far as the entire pattern goes, B, C, D, E, F, G, H, I matches the pattern. And then anything that's in parentheses will get pulled out as a capture group. So here, BC is its own parentheses. This is the first capture group, and DEF is in its own capture group. So that becomes a column here. Over here, this is telling you what part of the pattern matches, and it's MR, MRS, and MS. And then it pulls out the portion in parentheses that match. And in this case, because the entire pattern is in parentheses, it also pulls out the entire pattern here. Okay. Here, I put the names or the titles MR, MRS, and MS in this order, and it's going to give preference in it reads left to right. Okay. So what happens? Okay, sorry for the text here, is that it's going to find a match for Mr. Smith, and it pulls out MR. And then when it looks at Mrs. Lee, mrs.lee, it finds a match at MR here. And because it reads left to right, it goes, ah, I found a match and I'm done. Okay. And so you want to kind of put the most restrictive one before the less restrictive ones, right? So MRS is a little bit more restrictive. It's a little tougher to get that match than it is to get this one. And you have to kind of put it in that order. Otherwise, it's going to just pull out the MR here, right? And that would be a mistake as far as pulling up the titles. Might have made this. Okay. So here, this is I didn't use any or operators. I just used question marks. Okay. So this would match M followed by an R. Yes, or the question mark is a 0 or 1 operator. Okay. So this says M followed by an R maybe, followed by an S maybe. Okay. And so we get MR, MRS, and MS. So this is kind of like an alternative. What will this match that's not really a title? It will match also just a capital M all by itself. It will match just a capital M all by itself. Okay. Here, so here I've got the capture group. We want MRS, MS, MR, followed by a literal dot, followed by a space, and then we're going to take any word characters, any one or more word characters. Okay. And this is in a capture group. Okay. So when I run this, it's going to pull out the entire text that matches, and that's going to go in the first column. Mr. Smith matches this entire column. And then this is in parentheses, so it extracts that out. And then this part's in parentheses, so it extracts that out as its own column. So from this thing, which had people's names, Mr. Smith, Mrs. Lee, Ms. Garcia, and Andy Hope, it pulls out the Mr. Smith, Mrs. Lee, and Ms. Garcia. Okay. It also, the commas aren't part of the matching, and it pulls those out, and it pulls out their titles, and it pulls out their last names. Okay. And so this is kind of where the power of capture groups come in handy, right? So you can say, I want something that kind of looks like this. This is how I'm expecting people's names to be written. And this part, right, is the part I want captured, right? And so in your homework, I mean, some of you guys are like way ahead in your homework, and some of you haven't started, and that's okay. You got until next week to, it's due next week. And when you're dealing with the managers, you have like wins and losses, and you want to be able to extract those out. So you're going to be doing a string match all, and you want to say like, hey, this part is wins, right? These digits, when you see digits here, before a dash, those are going to be the wins. The digits that come after the dash will be a loss. And you got to specify that in your pattern. What defines a word space only? Like, yes. So no. So a word. So words are defined kind of by word boundaries, which will be spaces, commas. A comma will define kind of like this is the end of a word. Okay. And the end of the line will define the end of a word. Okay. Word characters, which is what we have here. Word characters are capital, lowercase letters, and numbers and underscores. Okay. Is there a way to extract multiple patterns, or can you only do one? I'm not sure. You can only do one pattern, but you can have multiple capture groups here. Okay. So here you might say, I want everything that kind of matches this, but I don't want to pull out, I don't actually want to capture this. So I'm going to put this as a non-capture group. Okay. I put the question mark colon here, and we say, yeah, you know what? I need the grouping thing in order to kind of do this OR operation, because the OR operator, to say you want the MRS, the MS, or the MR, you kind of need to put them inside parentheses to kind of group them together. But you can say like, I'm not interested in the titles. And so here we get kind of the same idea, except we don't get its own column for the non-capture group. This is non-capture. And so the only part that gets extracted is the letters that come after the title. Okay. Andy Hope doesn't have a title, and so is not included in our output. Okay, either, well, at least this is what we're telling the computer to do, and so that's what it's obeying. All right, is this okay as far as the string match? It's a very powerful thing for regular expressions. Okay. So here, notice what I'm going to do. I'm going to say I want word group space word group, and then a comma. Yes or no? Maybe I want a comma. Maybe I want a comma. Okay. So this will match George Washington. Okay. John Adams, Thomas Jefferson. George Washington, John Adams, Thomas Jefferson. Okay. Now what I can do, okay, is, so this is what we matched, and we can say, you know what, take this thing and I want you to replace it. But what you're going to replace it with the second capture group. Okay, so the first group becomes /1 and the second capture group becomes /2. So replace it with the section capture group with a comma and a space, followed by the first capture group, followed by a semicolon. And so it's going to go through this text. It's going to basically do the matching. And George Washington, John Adams, Thomas Jefferson becomes Washington, comma, George, semicolon, Adams, comma, John, semicolon, Jefferson, comma, Thomas, semicolon. Okay. And this is done in one operation. This is kind of a find and replace operation where almost like magic. I mean, I think this is super impressive that we've gone through this thing, and, you know, I didn't have to, like, without regular expressions, I would have had to probably take this, put this into Excel, separate out the columns, and then I would have the left column and the right column, and then I would swap spaces, and then I would kind of like paste them back together. But here you can do this with just a single thing by referencing the capture groups, right? We're going to say, take the second capture group here, put a comma, and the first capture group. Hang on, let me. All right. Okay. So what does this say, right? So as you get more into regular expressions, you're going to start seeing patterns that look like this, and it takes a while to interpret what's going on here, right? So what does this pattern say? It says we want a word boundary followed by a capture group that consists of one or more word characters, followed by one or more space characters, okay, followed by a group of text, right? This is a /1. This is find a group of text that was captured earlier, followed by a word boundary. So what does that actually mean? This means we want to find words that got repeated, okay? The word followed by a space and a word. So we want to find an instance of a word that got repeated here, okay? And so it's going to go through, the quick brown fox jumps over, and we got the lazy dog here. And it's going to say, oh, you know what? Here is something that matches, right? It's going to find the, followed by, which is going to be this word thing, followed by a space, and then it finds the same pattern that it discovered earlier. So so patterns, words that get repeated will match this. Oh, I'm gonna run out of time. Okay, so this will match a phone number, right? And so I try to explain all of what these things do, right? So parentheses optional, okay, because sometimes phone numbers are written this way. Yes, /1 is the first capture group that got captured, which in this case would be the, okay. Optional parentheses, a capture group that starts with digits 2 through 9, because if you have a phone number in the US, you can't, your area code can't start with a 1 or a 0, okay? Followed by any 2 digits, followed by either a dash, a space, or a dot, okay? Again, followed by kind of a prefix, followed either 2 through 9, followed by 2 more digits, and then followed by any 4 digits, okay? And so here, this is all of the text. We got Apple 1-800-796 this, 310 this, 310, 310 this, work, home, and this, okay? And so this pulls everything out, okay? One shortcoming of this Okay, and it doesn't match this because this is not a phone number that starts with a 1, and there's no phone numbers that start with a 1. Okay, one shortcoming of this is this person listed 2 phone numbers, a work number and a home number, and so it only pulls out the first match, which is the work number. If you do string extract all, then it will go through and it will find both of these, and it gives each of them their own thing. Okay, where it doesn't find a match, the apple gives you a character 0, and here it gives you a character 0. And this tells you what the pattern that matches. Okay, and because we defined capture groups here, okay, so these are all kind of formatted a little bit differently with different parentheses and spaces and dots and stuff. We can take those, we can use the capture groups, and we can kind of clean this up, right? So anyway, so you can run through this here, string match, and or string match all, and you can take everything and you can kind of just bind everything together, and you get kind of some phone numbers to extract and to clean them up, right? Okay, so anyway, this is just more stuff. You can kind of flip through it. I've got look arounds. You can look at these slides, but if you don't get to it, that's all right. But I'd say this is good enough as far as our exposure to regular expressions, and you can look at these remaining slides on your own time. Let me give you your last quiz answer for today. Last quiz answer is E. E as in elephant. E as in elephant. Okay, and that will wrap it up for regular expressions. And so we'll see you guys next week. Have a good weekend, and we'll see you guys on Monday.